All right, looks like I get a impressive walk-on video. See, what one year when I was speaking at Devox, I actually got to ride a motorcycle onto the keynote stage because I was doing a cross Europe motorcycle tour. Not as cool as the motorcycle in the Tron clip that we just got though. Okay, so really pleased to be here, chatting with all of these folks. A lot of folks in the audience I recognize. Really excited that you're out here to hear about graph technology, about agents, about MCP. And I'm going to talk a bit about those first. So I'll cover a bunch of the technical topics to get everyone on the same level. Then we'll go through some analogies and some ways of thinking about this and talk about use cases and applications. And then we'll do a demo because it wouldn't be a proper Devox talk without a live coding demo, which may or may not fail spectacularly. So I think it's always exciting to see live coding on stage and see how things come together in real life. But to start out, let's talk about failure first. And so I rarely trust analysts. Are there any analysts in the room? Okay, thank God. Last time I gave this talk, one of the Gartner guys was sitting in the audience, so I didn't complain too much about them. But I rarely trust analysts except when they're predicting colossal failure. And Gartner predicted that 30% of GenAI projects will fail by the end of this year. And when you look at the reason why that they predicted the failure, and this is actually happening, we've seen a lot of this, and even Rod Johnson talked about in the keynotes, the primary reason they cited was misalignment of business value with the applications and the uses of AI technology. So this is a huge problem in our industry for making sure that when we pick up a new technology, we actually find good use cases for it. We find applications which work. And also, the secondary problem was getting good results out of LLMs and large language models because of problems like hallucinations. So what we're going to do is we're going to take a quick example. So I have an example here, a word problem. So I did this originally with the O3 Reasoning AI, so basically GPT-4. I redid it a couple nights ago with GPT-5. Same results. GPT-5 hallucinates exactly the same way. But let's see how you guys all do versus the latest GPT models. So I'll read out the problem, and we'll do it in two steps. So we'll do the first part of it and the second part. And then we'll see how the Devox audience does. So a school has an elective course choice of computer science, home economics, or sports. And the computer science class has 36 students sitting in a grid of desks. All the desks are occupied. None of the girls is sitting next to another girl, either across from or diagonally from them. What's the maximum number of girls this class layout allows for? Okay, now, I mean, obviously, I mixed in a little bias here, right? So I think that, if you saw my daughter's keynote this morning about getting kids involved in technology, it's really important to get kids involved early. But there's still a gender divide between number of men and women in computer science technology. So we can use a lot of improvement here. And the LLMs know about this bias. So they already have a preconception about the number of girls and number of boys in class. So it's a little bit of a bias check as well in the LLM. So how would you all go about solving this problem? And you don't have to raise your hand. Just kind of shout out or start talking about like how you would think about solving this problem. You don't have to give the answer, just like a conceptual framework. Anyone have an idea? Okay, I hear somebody mumbling over here. What? 4. Is that the answer, or is that how you'd solve it? Okay, I heard 9 in the audience. Now, how did you get to 9?
Just 3 in a row, and then the next row there can't be any, and then 3 in a row, and then 4 times.
Okay, so you have like a 6x6 grid, and then you can fit 3 across, and then you kind of go down from there, and you get a max of 9 with leaving gaps. Okay, what do the rest of you think? Is that a good approach? Are we at the max? I see someone raising his hand. What do you think? Ah, okay. Okay, so maybe if we had a grid which was one row, one block high. Yeah, I'll repeat. So basically what he's saying is if we have a grid which is one block high and 36 blocks wide, we might be able to fit in more girls than 9, right? Because then if you skip one, you get 18 girls. So is that what you were thinking? Yeah. Okay. So maybe we should discuss like what potential grid sizes we can have. And I drew some diagrams here. So I have the 6 by 6, which is what you did. I have 3 by 12, 4 by 9, 2 by 18. I left off the 1 by 36 because it felt like cheating. I mean, maybe technically, I don't know what the definition of a grid is. Maybe a grid is 1 by something is also a grid, but I figured we should at least have 2 in one direction to make it a grid. And then if you do the algorithm you spoke about for skipping cells, then we end up with 9, 12, 10, and 9 for these. So what do you all think? Is 12 a reasonable answer for the max? Yeah. Okay. So let's go with that for human consensus. Okay? All right. Now, let's see what the LLM did for the same problem. And so I left it on the reasoning AI, so you actually see it, thinking through the problem. And you don't need to read all the text, but basically what it did is it actually took 40 seconds to reason about it. It looked through research and different things which related to this. And it came up with the non-attacking kings problem as the reference for this. And you can repeat this reliably. Like GPT-5 will come up with the same source material. And it treats this as a game problem, a chess game problem of kings not being able to attack each other, because it's the same attack pattern as kings on a chessboard, and chessboards are square. So therefore, it has to be a 9 by 9 grid, and then you have or a 6 by 6 grid, and then you have exactly 9 maximum girls allowed. So, big fail on the LLM, but Devox attendees did an awesome job. So give yourselves a round of applause. And you can see that the challenge here is that if we're building a business system, if we're building a supply chain system, like something that's doing analysis of pharmaceutical chemicals, analysis of transactions of trades, if you don't know exactly what the source material or the reference that it's anchoring on when it answers a particular problem or a challenging business problem, it's very, very hard to guarantee it's giving you good results, because LLMs do very unpredictable things based upon their source material. And then the second half of this, the teacher's a harsh grader, 75% of students fail a class. How many new students join the home economics class? So basically, the computer science students who leave can either join sports or home economics. So anyone have an intuition on how to solve this? And again, just shout it out or raise your hand or whatever you're comfortable with. Okay, so the gentleman in the back said not enough information. This is actually an indeterminate problem, right? But LLMs never give up. They never tell you that I don't know the answer. They will authoritatively tell you the wrong answer, as ChatGPT does. And it gets baited by the first half of the problem, and it assumes that that's part of the answer when actually it doesn't matter. And it starts looking at the number of girls who fail out, and it calculates 6.75 girls fail out. And then it says, well, obviously, all failed girls, 7 in number, will join the home economics class. So girls can only join home economics, and boys can only pursue sports. So we've triggered yet another bias in the LM by giving it a logic problem and then having it give us a bias that if you asked it directly, is home economics a class that only girls can go to? It would tell you, well, of course not. Girls and boys can both pursue it. Actually, I loved home economics when I was a kid. It was actually a lot of fun to chop up cabbages and vegetables and throw them in pots and cook them. So I think that this is something where it's a very unfair bias, but it comes out only when you trick the model into doing something complex with reasoning, with other processes. And the reason for this is the LLMs are really only working with half of a brain. So they're very good at things on the right here. They're good at imagination, holistic thinking, intuition, arts, rhythm, nonverbal cues, daydreaming, hallucinating. They're not very good at more analytical things, so logic, sequencing, linear thinking, mathematics. They only know the facts that they're trained on. So if you have like a private data set or things which you're trying to get from a corporate data set, you have to train separately a vector database. And they don't think in words, they think in word vectors. So they think very differently than humans do. Okay, so maybe we can make this better by having more LLMs, right? I mean, this is the modern answer to this. We build agentic systems, and they talk to each other, and they solve this all. And I think I have a good analogy for this, thinking about agents. And it's something which probably a lot of us watched as cartoons in the 80s, and I think it perfectly describes the current patterns for improving LLMs with agents. Okay, and the amazing transcriptions working and giving us subtitles for our Saturday morning cartoons. Anybody watch Super Robot shows when they were kids, or maybe even adults? I mean, they're getting quite trendy now as well. So this was one of the ones which came on early to the U.S. I'm not sure if it also made its way to Europe, but it's funny because the little individual lions, they just get beat up the whole show and kicked around by the monster, and they always lose. But then at the end, they transform into this big super robot, and then they vanquish the monster, and then repeats every episode. So I think this is a good pattern, right? We can do better with agents. We can build better agentic systems. We can have LLMs which have different roles and solve different problems in the system, and therefore we can build more complex systems than we can build if we're just dealing with a single LLM. And so now you can have agents which observe and kind of look at the situation and kind of come up with plans. Agents which do thought and reasoning to try to control the system. Take actions by calling tools. And then we can automate more complex workflows with these systems by combining a bunch of agents together. Use reasoning and planning to determine the steps, and then use MCP tools and things to augment our agents. So this is kind of the modern pattern for building agentic applications. How many folks are already using agents? Okay, so quite a number of hands. Now, the simplest agent is you just have an LLM calling itself in a loop. So even if you're not using agents, you're probably using agents because that's pretty much what all of our systems are doing. And here's a really simple runtime for an agent. So we have an end user making a query to the agent runtime. And then the agent runtime has the orchestration layer where that's kind of your agent brain, where you come up with the goals and instructions for it. You have short and long-term memory, so you can remember the current transaction with the user and what the LLMs are talking about, but then also have a history of things which were previously answered, so you have a longer history for it. You can do model-based reasoning and planning, and then use a variety of Gen AI models, so we can use multiple different models for different roles based upon which model performs the best, and then call out to different tools like APIs, functions, databases, etc. So this looks like a pretty good architecture, right? Now, there's some challenges with this, and basically this is a tight coupling because now you have everything inside of your agent runtime box. So now you have all of your code for calling tools mixed in. You don't really have standard communication frameworks built into this. You're tightly coupling it, and since you don't have standards for this, you have kind of this complex many-to-many situation where you're calling multiple databases or multiple APIs. You need to do that for each of your applications internally at your company. You're not reusing it. It's hard to secure this architecture because now you have a lot of repeated code calling different tools. And generally, you're getting lower quality tools and outputs from a system like this. So I think we can do better and use model context protocol. How many folks are already using MCP in the audience? Okay, quite a number of folks. Actually, looks like the same people who raise their hand for agents. It kind of goes together. And MCP, you can kind of think of this as the USB analogy. So it's a USB-C port for your AI applications. It kind of standardized how tools connect and talk together. It's an open protocol developed by Anthropic, and it's very, very easy to write MCP tools, to wire them into your applications, and then to share them. So you can call them from your development tools, set them up in your IDE. You can call them from command line tools. Now Claude Code command line. We'll do a demo of that. Some of the ChatGPT and other tools allow you to connect MCP tools to them directly. And of course, you can build your application so the agents in your application have access to different MCP tools. Now, I hate USB examples and analogies because it's so generic and everything's a USB port. But going back to our super robot example, I think we have a much better tooling example of this with a clip that is slightly higher in volume than the previous one.
Form blazing swords!
Okay, so you can see that our our super robots now have tools as well. So they get giant swords or weapons that they can fight and vanquish the bad guys. Kind of like our agents get MCP tools so that they can actually build and solve more complex problems. And so MCP is an open protocol. I mentioned it's originally developed by Anthropic, but now it works with all the different LLMs. It follows a client-server architecture. So you build your MCP servers, which connect to different data sources or different end tools and products. Those are called by your agents or your clients. So this could be IDEs or different tools which you're calling. They're composable, modular, shareable, reusable. Much easier to secure now because we have individual tools that we can add security to and isolate. And much easier for us to now give new capabilities to our agents. So we can give it a whole bunch of tools and it can pick which ones it wants to use. Now, I don't know. We've been playing around with a lot of agents at Neo4j, and actually one of the things we've noticed is another failure pattern is giving your agent too many tools, because then it doesn't know the right ones to use, and it kind of trips over itself trying to figure out and chooses the wrong tool. So that's something else to watch out for as you build even more complicated architectures using MCP tools. The basic protocol is you have a stateful, persistent, and bidirectional connection between your client and your server. The MCP client invokes the tools, queries for resources, interpolates the prompts, and the MCP server does the corollary of exposing those. And some examples would be if we wanted to do, invoke a retrieval and search tool, it would expose files as resources, and then it will give you document Q&A as its prompt. If you wanted to do a tool which sends a message, it might expose database records and give you a transcript summary. Or if you want to update database records, it could have API responses and then give you output as a JSON for the row updates or the sort of operations that are done in the database. So this kind of gives you a flexible architecture for building tools. We have a bunch of open source tools which we built as open source GitHub projects. We have an MCP Neo4j Cypher tool, and we're going to play around with this one a little bit, but basically what this allows you to do is it allows you to call Cypher, which is the query language for graph databases, directly from your LLM. LLMs actually are really, really good at creating knowledge graphs. They're also good at constructing Cypher queries, and the later models have become really good at this. Claude was always good at this, but now the GPT-5 models are equally as good. And also, they're very good at using and storing information in graphs for memory. So that's another great use case for this. We have a memory, Neo4j memory MCP server as well, which allows you to store information knowledge graphs. One for Aura APIs to access cloud services, and then one for data modeling, which allows you to create and visualize and manage your graphs as well. And doing this is not just for using graphs is not just for MCP. It's also for building your agent workflow. So if you're using tools like LangGraph, then you can have all of your agent connections for connections and the routes between them as part of your workflow. And also you can use it for stateful connections for sending and receiving information. Just a sec, because we're going to keep hearing that ping unless this one dies. There we go. I think for you guys working in Europe, you're probably quite familiar about this, but this is around the time the US wakes up and starts harassing you for things, right? So all my colleagues over in the US are happily waking up and responding to Slack messages and emails. So you can also use it for agent memory, short and long-term memory. So all these companies, Zep, Mem0, and Cogni, are using graph technology as the underlying storage for their memory. Zep does some cool stuff with graphs which store time information on top of regular graph databases. So they have their own open source project which does that. And then that can sit on top of other graph databases like Neo4j. Mem0 similarly has a bunch of pluggable stores for their agent memory, including graph databases. And also Cogni is doing some cool research in this. And I was actually on a panel with all of these folks at AI Engineer World's Fair, where we chatted through a little bit about what they're doing and how they're architecting their product. Also, NVIDIA is using graphs as well. And this is a diagram from their public repository about their search and retrieval agent. And actually, they just had a press release, I believe, today or yesterday as well, talking about their use of graph technology in their products like the search and summarization pipeline here. And basically, you see it's a data processing pipeline for doing video decoding and summarization. And it takes two paths for the output. So it puts things inside of a vector database. So if you're using your favorite vector store to store information, you can stick it in there and you can get similarity searches on it. They're also doing a GraphRAG pipeline. And so they're putting things in a GraphRAG pipeline, which is a graph database, and storing this knowledge graph and then retrieving it that way. And then, of course, this all goes into memory, into agent systems, and then gets a user response. So the question is, if we have agents and we have MCP tools and all this cool stuff, why are we also doing lookups in the knowledge graph? And the reason for this is it's really, really good at removing hallucinations. So what we talked about earlier with kind of the left-right brain, the knowledge graph as the left brain really helps the LLM to reduce hallucinations. And here's a pharmaceutical example. So this is basically the same query being processed by an LLM directly, where it doesn't have any specialized knowledge. Baseline RAG, where it's using a vector database to get additional context and doing a similarity lookup. And then GraphRAG, where it's doing a lookup on a knowledge graph, which has been built off of pharmaceutical information. So the question is, what is in the care plan associated with Andrea Jenkins' emphysema? And if you ask the LLM directly, it gives you a very generic answer. Preventing further damage to lungs may involve advising the patient to yada, yada, yada. So it doesn't know anything about the patient specifically. It doesn't have a very laser-focused response, but it can give generalization. The baseline RAG does better. So it pulls out a bunch of activities from the care plan. So respiratory therapy, deep breathing, coughing exercises, but it's incomplete and not very specific. And the GraphRAG example, basically you're getting direct context and all of the care that's associated with the health plan, and it gives a more definitive response. So medication management, smoking cessation counseling, pulmonary rehabilitation exercise. And this is close to what a doctor would require for working with a patient, right? You need to have very precise, detailed information and complete information to be able to give patients health diagnosis and to give a more detailed diagnosis. And this is kind of the pattern for what's happening in that right case. So the user is asking a question to the GenAI application, and it's doing a graph retrieval, and it's doing two things in parallel here. So it's doing a vector similarity lookup first, and then it's doing a graph traversal second. And so the vector embeddings are stored in the graph database as properties on the nodes. And it first looks up and tries to find, what is similar by doing a vector lookup. And that's the easiest way to take a question and to get a range of possible outputs. And so it'll pick up the patient's name, it'll pick up the condition, and it'll pull back related information from the vector database. But it's not very specific. So what you do is you then get the nodes associated with that, which will be the patient and the condition. Pull back related nodes by cosine similarity or community grouping or other graph algorithms. And you pass in those portions of the knowledge graph into the LLM as the context along with the question. And then the LLM can give a very specific response. And so that's basically what's happening in the second example. And when I show the demo, this is the first style I'll do it in, and we'll do a second style to kind of juxtapose the two so you can see. So we're going to do, that's basically the bottom left one, vector search with graph context, using graph patterns to retrieve items related to the vector search results. We will also do the bottom one, agents and multi-step. So we'll combine tools together, and we'll have agents call using MCP tools and kind of a loop and pattern. Text decipher is probably where most people start with querying knowledge graphs. It can be very effective, but the challenge with text decipher is sometimes you can't get the LLM to generate a cipher query. Cipher is the equivalent of SQL for relational databases, which will give you the right results back. So it might take a few steps to get there, hence the agent and multi-step. Graph vectors is just similarity search, so it's basically a vector database. And then graph filtering is helpful if you're trying to do something like a page rank algorithm or maybe like sorting results in a shopping application or something, where you can use the graph database to reorder the results coming back from the vector store based on relevance. And this pushes things higher up in the context. And people are getting quite good results for this with anything where you need to do kind of a ranking algorithm. Okay, so knowledge graphs give us some ability to do governance as well. So if you have, for example, a customer service agent, they should have access to the phone records, but not to the health diagnosis of the patient. Similarly, a doctor should have access to the health diagnosis, but not any of the phone number, any of the information about the patient. And so this is easy to do with the knowledge graph because you can then put information or properties on the nodes about access control. When you pull back information in the cipher query, you can restrict which nodes or which properties the individual persona has access to, and then give the LLM only the information which it's allowed to see to answer the question. So this can be quite effective as well. And it also helps you with explainability and auditing of your application. So one of the big challenges with building applications purely on a vector store is it's kind of a big black box. So you ask the vector database a question, it gives you back, a whole bunch of results, and then you give those back to the user, or as context to the LM, who then gives it back to the user. And it's very, very hard to explain why it chose those particular vector embeddings because they're statistical probabilities. They're kind of very difficult to decipher. And so you're guessing at why your application is performing good or poorly. With passing graphs in its context to the LM, it's very discrete, and you can audit and know exactly what knowledge is being passed into the LM because you have a graph which humans can reason about. Okay, and before we get in the demo, a quick use case, which I think kind of highlights how you can use GraphRAG and some of the use cases for it. So this was Sebastian, co-founder and CEO of Klarna. And he was featured in TechCrunch because they built a system, it's called Kiki, is their knowledge system, and they displaced thousands of SaaS applications from their organization and replaced them with this consolidated single source of information as an agent for their employees. And what they did with Kiki is they took all their HR systems, Wikis enterprise systems, internal documentation, support, CRMs, etc. They put that all inside of a big consolidated knowledge graph, and then with an LLM on top of it and using GraphRAG for retrieval, they gave it to their employees, and they were able to answer 250,000 questions, hit daily processing of 2,000 daily queries, and then had 85% employee adoption of the system. And this helped them to reduce the reliance on siloed applications in their organization. And like examples of this would be if you have somebody doing customer support and they're trying to look up a knowledge base and then answer a question about it, they may not be aware that that customer is up for renewal in a month. And this is very time critical because if they're not successful, then they may not renew. It might be an issue. So then with this more full knowledge of the organization and the folks they're working with, it helps them to optimize their workflow and help employees to be more productive with a fuller view of the whole business. Okay, and let's go into a demo of this system and see if we can actually build a GraphRAG system in the remaining 18 minutes that we have to us. Okay, so you guys get to see my fun Linux desktop because I decided to ditch Windows and proprietary operating systems, and mostly it's working. And we're going to use this tool today called the Knowledge Graph Builder. Now you can see that I did some stuff in here before, but we don't want to see that. We want to start over from scratch. So basically what I did is I did this afternoon. I created a new Aura instance. Aura is the cloud version of Neo4j. And we're just going to do something horrible, and we're gonna flush our database. I don't recommend doing this in the middle of a live stage presentation. And what this will do is this will remove all the relationships, all the nodes, all the connections, because we want to build a knowledge graph from scratch. So we're going to take a few different source files and then import those in. We're going to have the LLM build the knowledge graph for us. So we're going to use an LLM to actually create all the relationships and actually define this. And yeah, we should hopefully be getting these to 0, and then our graph builder will be fleshed out as well. So let me refresh this and see if our LLM flushed successfully so that we have a clean slate. Our database is flushed successfully as a clean slate. Not quite. Almost there. So we're gonna flush the database completely, so we kind of start with the 0 and we can populate everything. And then once that's ready, then we'll populate it with new information. But this is a great time if anybody has questions that I can answer while the database is flushing. So any questions from the audience for things that I've already talked about that you kind of want more detail on or you want me to expand on? Oh, it's flushed. That's a good observation. That doesn't count as a question. All right, I think I'll have some time for questions after the demo. But now that we're flushed, let's check the Knowledge Graph Builder. Okay, so good. Okay, we have an empty slate now. We have a clean database, and basically what this tool allows you to do is it allows you to load up things and upload files. So we're gonna upload a couple things. I'm gonna upload a BOM file. BOMs are bill of materials for software life cycles. So you can get these from exporting from tools like Artifactory or Nexus or other dependency managers. And we're also going to take a VEX file. VEX files are information about security issues, and they include not only the security disclosure, they include information about remediation steps on it. So I picked a couple representative BOM and VEX files for us to process. And then what we're going to do is we're going to select these, and we're going to generate a graph off of it. So this now what it's doing is it's asking the LM. In this case, we're using OpenAI GPT 4.1 model. You can choose your model of choice. And it's going to add these to the graph using the LM to create nodes, to create relationships, to create structure for it. And then we can actually look at the graph and visualize it and see what it put together from the documents. This is behind the scenes. This is all an open source project, so you can actually look at the source code for the Knowledge Graph Builder. But it's basically using LangChain together with some of our Neo4j tools to import and to get all the information in. And then you can see it's doing some additional steps, materializing text chunk similarities, enabling hybrid search and full text in Bloom, which is a visualization layer. And then something else which I couldn't read in time. Okay, let's get a preview of the graph and see what we got. Okay, so here's our our graph, and there, it's colored by nodes. So we have some chunks for the chunking up. We have some nodes for advisories and documents and different characteristics. Every time I do this, the graph looks a little bit different, and we'll just randomly zoom in on an area of the graph with a trackpad that hates being zoomed in. Oh, there we go. Okay, so we can see like here, for example, here is a license. So the library we're analyzing has an Apache 2L license on it. And so you can see that this kind of gives us a whole bunch of information. Some of these nodes at the end here. Yeah, general purpose, data something, DOM serializer. Oh, okay, so this must be the Jackson library. So you com faster XML Jackson. Okay, so we generate a graph off of it, which we can now start to ask questions. And why don't we go over, and this also has a built-in chatbot, so we can talk in and we can ask questions. Let me see if I can make this bigger. Used to be bigger. Okay, well we'll just run with it. Okay, so let's ask it. What do you know about? All right, so somebody give me a random Java library. We're going to try to trick it and see if it will lie to us. What? Spring. Okay. What do you know about vulnerabilities in the Spring framework? So let's see what it says. Let's see what it thinks it knows about Spring vulnerabilities. Oh, there we go. Now, okay, now we have full screen. Oh. Okay, so this is really good, right? We asked it a question which it shouldn't know anything about, and it didn't try to make up an answer. It didn't try to hallucinate on us. So that's amazing. All right, so let's ask it, what do you know about vulnerabilities in the Jackson library? Let's see what it says. Since we know that there was something about Jackson in the tree, it should have information it can answer and tell us a little bit. Okay, so it gave us a specific library version that it knows about, Jackson data bind version 2.10.0, a CV number, which it has, with a severity of 7.5, and then information about data flow analysis. So basically, the data flow analysis is the VEX part of the stack. So it's something that won't be fixed, and you can get more information in the database. So this is pretty good, right? So we got some information. We got it from the graph database, and it wouldn't hallucinate when we tried to trick it. So that's good so far. So we're gonna do a second thing now. So we've already built the knowledge graph, but wouldn't it be cool if instead of querying the vector database and then jumping over to nodes and passing on as context, if we could use MCP tools like the cipher to text to cipher to query it directly. So what I did, again, this afternoon before the presentation, is I quickly set up my Claude desktop. And if we go into settings, you can see that I gave it an additional tool, which is the Neo4j Cipher MCP server. I configured it with the database settings, so it can access the database. And just so you know, the tool definition has a few keywords. So if you mention graph database or something related to graphs, then it will use the tool. If you don't, it will just search out of its knowledge. So let's see if we can get this to do something useful. All right, so what is mentioned in the graph database about vulnerabilities in the Jackson library? It's kind of random. I don't think I worded it this way last time I tried it. So hopefully it does something useful. Okay, now you can see it's doing tool calls. It's reading the Neo4j cipher. It's getting the schema. So the tool can reach out and get the schema of the graph database. Now it's doing a query to look for like Jackson related info in the database. Details about vulnerabilities, so it's kind of hopping around to find vulnerability information. Pulling back full chunk information, so it has like full context to give a very detailed response. Reading advisory and recommendation details. And then it has its answer, which is similar, right? It's the same CVE that it mentioned previously, but it's actually very detailed. So it tells you the affected components, the threat level, the attack vector, remediation options, additional information. So like a very thorough response, because it was able to iterate over the tool and then pull back all the information needed to give a very thorough response. So I think this is a good example of kind of juxtaposing the type of results you'll get from graph with vector, which was the first approach, versus using kind of an agent MCP model, where in this case it's a simple agent, right? It's Claude calling itself in a loop, but it's able to get the schema to like query results back and then keep following that thread till it gets a very thorough answer. Okay, so that's the demo I wanted to show you all. Back to the presentation. Somewhere. Oh, here we go. Okay, so we saw all this. We saw that output. Oh, and okay, and then at the end of every episode of Ultron, you always have to kill and vanquish the bad guy. So I think it's appropriate now that we've finished our demonstration and we've actually gotten working MCP tools against a graph database. Definitely the bad guy is going to get vanquished, right? Okay, I see a lot of nodding.
Zaporobi!
All right, so with that,
Way to go, team!
we'll skip that. So we've seen how we can use agents, how we can use MCP servers, reduce hallucinations, hopefully improve business value. Now, I have a couple of resources for like learning further from here. The first one is Graph Academy. So my team at Neo4j builds this coursework. It's free online courses. There's courses to build chatbots in various programming languages, to learn Cypher, intermediate and advanced Cypher classes. So even if you know Cypher, it's good to kind of learn some of the more in-depth queries. And also certification, so you can get certified and you get one of these t-shirts on our community platform. So this is a great way to learn. And when people drop their cell phones, I'll go to the next resource. Okay, looks like we're good. Next thing I'd highly recommend is we have the Nodes Conference, which is an online conference, November 6th. So like DevOps is an amazing event. But if you're specifically focused on graphs, this is the kind of the big event of the year to go to. And we have 4 different tracks on AI engineering, app dev, data intelligence, and knowledge graphs. And we have specifically European time zone sessions. So you can watch all the European time zone sessions. Actually, I'll be in India at another conference during this. So I'll be on European time zone, essentially. And this is also something we just announced in the past week, which is myself, Michael Hunger, and Jesus are working on a book for O'Reilly called GraphRAG, the Definitive Guide. The first few chapters are available, so you can actually download those and read those now on Safari or the Early Access program. And we are hopefully going to be much earlier than September, but that's what O'Reilly thinks we'll do. But we're planning a full 12-course, very detailed, kind of authoritative guide on everything on building GraphRAG applications, doing agents, doing retrieval, doing MCP, and a whole bunch of different patterns for knowledge graph construction as well. Okay, so with that, thanks everyone for coming to my talk today. And I'm happy to answer more questions. Why don't we do this? Just come up to the front of the stage, and then we can chat in a group for a bit. So thanks, everybody, and enjoy the rest of the conference.